You know, when most folks hear AI, they probably picture futuristic robots, right?
Yeah, the sci-fi stuff. Humanoids thinking machines.
Exactly. But the reality, especially now, is that AI is often less about that and more about really smart number crunching. It's kind of like a superpowered evolution of statistical analysis.
That's a great way to put it.
Yeah.
Things many people have already done, maybe in Excel.
Right. Like if you've ever used Excel for sales forecasting or finding trends or trying to figure out if your marketing spend actually correlates with signups,
Hmm.
that's the same basic idea, the same logic that's under the hood of a lot of today's AI, particularly machine learning.
It really is. The AI making headlines today is mostly about finding complex patterns in data and using those patterns to make predictions.
And that's exactly what we're diving deep into today. We're looking specifically at the AI scene in China around 2020.
Right, focusing on the infrastructure being built then
Yep.
and how AI was actually, showing up in real life.
Yeah, our mission here is to cut through the hype and understand the actual progress, the foundations being laid in China at that time based on the material we've reviewed.
Absolutely. And to really understand how mature an AI industry is, you got to look at the core components.
Okay.
So we'll be looking at China's talent pool, the AI scientists,
Mhm.
then their ability to handle and learn from just massive data sets.
The fuel for the AI, basically.
Exactly. And finally, the crucial role of ongoing investment and a supportive system, what our source calls
The
TUI.
overall environment.
Yeah, the capital, the policies, the national strategy. Then we'll look at how all that came together and some pretty interesting real-world examples from China back in 2020.
Okay, sounds good. So let's kick things off by tackling this idea. Our source mentions the AI disillusionment phase. That sounds pretty negative, like AI was failing.
It does sound like a downer, yeah.
Hmm.
But if you look at, say, Gartner's hype cycle research from Japan around that time, it's a bit more nuanced.
Nope.
This disillusionment wasn't really about AI itself being a bust. It was more like a market correction. You had this peak of inflated expectations, loads of hype.
Right, everyone jumping on the bandwagon.
Exactly. And then the disillusionment phase is when the lower quality products, the ones that couldn't really deliver on the big promises, started to, fall away.
Ah, okay, like maybe some early smart home gadgets that were just clunky and didn't work well.
Precisely that kind of thing.
Hmm.
So it's less an AI winter and more the market just weeding out the stuff that wasn't ready for prime time.
Got it, makes sense.
And what's really interesting is the argument our source makes here. Far from being some passing fad, AI, especially machine learning, was actually becoming a fundamental skill.
A core skill, like for business professionals.
Yeah. They draw this really strong parallel to how indispensable Excel became for anyone dealing with data.
Yeah.
Inputting, analyzing, even basic forecasting.
That's a good comparison. Everyone uses Excel or something like it.
Right. And the idea was that machine learning was heading down that same path. You started seeing more entry-level data jobs, expecting at least some familiarity with basic ML concepts or tools.
So the core functions of machine learning,
Yep.
prediction and classification, right?
Exactly. And those are tasks people were already attempting, maybe crudely, with tools like Excel. Our source even hints at a future where spreadsheets might just have ML features built right in.
Imagine that. Predictive power right there in your spreadsheet.
Yeah, giving everyday users access to some pretty powerful capabilities within an interface they already know.
So you mentioned ML becoming more accessible. How did that actually happen? It always felt like this super specialized field.
Well, a huge part of it was the explosion of really powerful yet relatively user-friendly software libraries, especially in the Python programming language.
Ah, Python. Libraries like.
Things like scikit-learn, which is great for general machine learning tasks.
Hmm.
And then for the more complex deep learning stuff, you have libraries like Keras and TensorFlow.
Right, heard of those.
These libraries basically package up a lot of the complexity, making it much easier to build, fundamental ML models. Our source even says high school students with some coding skills could start messing around with this stuff.
Wow, okay. So does that mean anyone could suddenly create super sophisticated AI back then?
Not quite. And this is a really critical distinction our source makes. Building a basic model, yeah, that became much simpler.
Okay.
But building a model that's actually accurate, reliable, and genuinely useful in the real world, that's a whole different ballgame.
Right. There's always a catch.
It takes serious expertise in things like parameter tuning, which is basically tweaking all the model's settings to get the best performance. And you need a really deep grasp of the underlying AI principles.
So it's like anyone can follow a basic recipe from a cookbook.
Yeah, exactly. But becoming a top chef requires years of practice, understanding the nuances, the techniques.
Gotcha. So just grabbing a library and running a basic model isn't enough.
Definitely not for complex problems. And the source suggests that a lot of the early negativity or disillusionment about AI came from people doing just that.
How so?
Well, they might try a simple off-the-shelf model, find it doesn't work much better than their old methods, and then just dismiss AI as overhyped.
Hmm.
They miss the crucial refinement and development steps needed to make it truly effective.
That makes total sense. You need the expertise to actually make it work properly.
You do.
Okay, so with that context about AI in general, let's zoom back in on China. Our source laid out 3 key pillars for a mature AI industry there. What were those again?
Right. The three essentials identified were, first, a strong base of talented AI scientists, people pushing the research
Through
forward.
the brains.
Yep. Second, the capability to handle and learn from truly massive amounts of data. We talked about data being the fuel.
Right, big data.
And third, consistent investment and that supportive overall environment, the capital and OD.
The money and the system.
Exactly.
Yeah.
Not just funding, but also government focus, policies, regulations, the whole ecosystem that helps AI grow.
Okay, let's unpack those, starting with the scientists. How was China doing on AI talent back in 2020?
Well, according to our source, China was already considered a top-tier player in AI talent by then.
Really? Top tier.
Yeah. There's even a statistic mentioned that Chinese individuals made up the largest single group, something like 29% of senior AI professionals working in U.S. tech companies.
Wow, 29%. That's huge. I do remember hearing talk around that time about the U.S. potentially restricting work visas for Chinese tech folks.
You do, yeah. And the concern, even voiced within the U.S., was that doing that might actually backfire.
How so?
The thinking was, if you restrict visas, these highly skilled people might just go back to China, which would end up boosting China's own AI capabilities.
Right, sort of an own goal.
Kind of. So the source concludes that while the U.S. probably still had a slight edge in overall AI talent then, China had definitely built up comparable systems for training and educating their own strong pool of experts.
Okay, so the talent base was solid. What about pillar number 2? The capital and the supportive environment.
This really points to the huge financial resources and strategic focus that China's big tech companies and the government were pouring into AI.
Big money flowing in.
For sure. Our source mentions Baidu, for example. People might have seen their search ad business slowing a bit, but the company was making a major strategic pivot towards AI.
Ah, Baidu. I remember their autonomous driving stuff, Apollo.
Exactly. Apollo is a prime example here. By 2020, it wasn't just testing anymore. It was moving towards actual mass production and, importantly, starting to generate revenue.
That's a significant step going from R&D to revenue.
It really is. Shows it's becoming a real business. The source also points to ByteDance, the TikTok company.
Right. Their recommendation engine is legendary.
And that's pure AI at its core. That incredibly effective recommendation system was key to TikTok's massive success, keeping users hooked with personalized content.
And ByteDance wasn't just using AI for TikTok, were they?
No, absolutely not. They were already taking that AI know-how and applying it to their expansion into other areas, education, e-commerce, gaming.
Diversifying.
Yeah. And beyond Baidu and ByteDance, the source briefly notes other giants like Alibaba, Tencent, Meituan, Didi Chuxing. They were all routinely developing and using AI across their services too. The investment and strategic commitment were clearly widespread in the tech sector.
Okay, so talent, check. Capital and supportive system, check. Now, the third pillar, which sounds maybe less exciting but seems absolutely vital,
Yeah.
large-scale data handling. Why is just having tons of data so critical?
Well, simply put, AI models, especially machine learning ones, learn by example. They learn from data.
The more data, the better they learn.
Generally, yes. The more relevant, high-quality data you feed them, the more patterns they can detect, and the better they get at making predictions or classifications.
Makes sense.
Our source uses the MNIST dataset as a basic example. This is the classic set of 60,000 images of handwritten digits used to train simple image recognition.
I think I've seen that one.
Yeah, it's useful for learning, but 60,000 images, that's tiny for real-world stuff. Often you need to massively augment datasets like that to get really high accuracy.
Okay, so it's not just having the data, it's also preparing it, getting it ready for the AI.
Exactly. That's a huge part of the challenge. Preparing training data is incredibly labor-intensive.
How so? What's involved?
You've got to collect it, obviously. Then you need to format it correctly, clean it up, remove errors, duplicates, inconsistencies, and then, crucially, you have to tag it or label it.
Labeling. like
Yeah,
telling the AI what's in the picture.
precisely. So the AI knows this is a car, this is a pedestrian, this is a stop sign. Even with all the data on the internet, this curation and preparation still requires a massive amount of human effort.
And this is where China's huge population became an advantage, right? Access to labor.
That's exactly the point the source makes. China recognized this need and the potential advantage. They even officially recognized a new job title, artificial intelligence trainer.
An AI trainer, seriously?
Yep. And they set up these large-scale data training centers, often in rural areas where labor costs were lower.
Hmm.
The Baidu AI Basic Data Industry base in Shaanxi is mentioned as a key example.
Wow. How big were these operations?
Well, that Baidu base in Shaanxi by 2020 reportedly already had 2,000 full-time trainers on site, plus another 50,000 people working remotely via the cloud. And they had plans to grow much bigger.
50,000 cloud workers. That's industrial scale.
What were these AI trainers actually doing all day?
It's often meticulous, detailed work. Tagging objects in images, like we said, identifying every car, person, lane marking and footage for self-driving cars.
Drawing lines on roads and pictures.
Exactly, or drawing bounding boxes around things. Very precise work.
Our source had a really striking example of this during the pandemic with face masks.
Ah, yes, that's a great illustration. So COVID hits, everyone starts wearing masks.
Right, and facial recognition systems stopped working so well.
Exactly. These systems were already common in China for things like office attendance, payments. Suddenly, they were much less reliable.
So what did they do? They deployed these AI trainers. Their job was to go back to existing employee photos and manually annotate key facial feature points, specifically around the eyes, the forehead, the parts still visible with a mask on.
Ah, so they were teaching the AI to focus on the visible parts.
Precisely. They provided new, targeted training data.
Yeah.
This allowed the AI models to be retrained to recognize people even with masks on, bringing those attendance systems back online.
That's incredibly practical. A direct human input to solve an immediate problem for the AI.
It really shows that human-in-the-loop approach. And the source suggests this ability to mobilize large-scale human effort for data prep might be a key reason why China, and potentially India too, could become dominant forces in AI implementation.
Interesting. It's not just about the algorithms, but also the massive effort needed to feed them.
Exactly. Groundbreaking science needs genius, maybe. But practical, widespread AI engineering often relies heavily on effectively managing and preparing these huge data sets. Okay, so China in 2020 had the scientists, the capital and supportive system, and this massive data handling capability. The pillars were in place. So what were some actual examples of AI applications starting to take off then? The source mentioned top 10 tech cases.
Yeah, it was common for Chinese tech media to put out these lists highlighting the big tech stories of the year, and several of them featured really impactful AI applications.
Like what?
One really significant one was Baidu launching something called LinearDesign.
LinearDesign. Sounds technical. What did it do?
It was an AI-powered system, and Baidu actually made it freely available to researchers globally back in May 2020. It played a pretty important role in speeding up the development of mRNA vaccines.
mRNA vaccines, right? The
Yeah.
COVID vaccines.
Yeah.
How did AI help there?
Okay, so quick background.
Hmm.
Traditional vaccines often use weakened viruses. mRNA vaccines give your cells the instructions, the messenger RNA, to build a specific viral protein, which then triggers your immune system.
Got it.
The big challenge is that mRNA is a single strand, and it tends to fold up on itself into complicated 3D shapes, like a tangled piece of string.
Exactly. And the crucial part of the mRNA, the bit with the instructions, needs to be easily accessible to your cell's protein-making machinery, the ribosomes. If it gets hidden inside those folds, the vaccine won't work as well.
Okay, so you need the right shape.
You need a stable shape where the important sequence is exposed. Predicting how that long mRNA strand will fold is incredibly complex computationally. There are just vast numbers of possibilities.
Sounds like a perfect job for AI, sorting through possibilities.
That's exactly it. Baidu's LinearDesign used advanced AI algorithms to predict these 3D mRNA structures really quickly, reportedly in as little as 16 minutes for a given sequence.
16 minutes, that's incredibly fast.
It dramatically accelerated the process of designing potentially effective mRNA vaccine candidates. And the fact they made it freely available worldwide was huge, especially given the urgency of the pandemic. The source even suggests checking out the LinearDesign website if you're curious.
That's a really powerful example. AI tackling a global health crisis. What else was happening on the ground in China?
Another really visible application was the widespread use of health codes for pandemic management.
Ah, the color codes on phones. Green, yellow, red.
Exactly. Usually in an app or a mini program from companies like Alibaba or Tencent, these became absolutely central to China's COVID-19 control strategy.
How did they actually work? And where was the AI?
Well, the exact inner workings weren't public knowledge, but the general understanding is they used a mix of data, likely location data from phones, maybe Bluetooth contact tracing.
Okay.
Then machine learning algorithms would analyze all that data to assess an individual's infection risk and assign them the corresponding color code. Green for low risk, yellow or red for higher risk.
And those codes determine what you could do, right?
Absolutely. Depending on the city's rules, if your code turned yellow or red, you could be barred from public transports or entering shops, offices, restaurants. A green code meant you could move around relatively freely.
So it created a strong incentive to, say, get tested if you might have been exposed.
Definitely. A negative test or completing a quarantine period would usually turn your code back to green. The source even mentions instances where if one person in an apartment building tested positive, the entire building might get red codes, leading to these very targeted, localized lockdowns.
Wow. That allowed them to keep most of the economy open while clamping down on specific outbreaks.
That was the idea, a
Uh,
very data-driven, AI-assisted approach to containment.
What about more everyday, maybe less dramatic AI uses?
Well, one interesting initiative the source highlights from 2020 was a directive from the State Council, China's main administrative body, pushing for an elderly mode on smartphones and other devices.
Elderly mode, to make them easier to use for seniors.
Exactly. Recognizing that standard interfaces can be tricky for older adults, and AI played a key role here.
How so?
Through AI-powered voice assistants, think of Baidu's Yaodu or Xiaomi's Zhao Aitongzu. These became central to the elderly mode experience.
So you could just talk to your phone.
Yeah. Older users could make calls, check the weather, get news headlines, play music or videos, all just using voice commands. No need to fiddle with small icons or complex menus.
That relies on good speech recognition, though.
Absolutely. And that capability was largely thanks to huge leaps in speech recognition accuracy, driven by machine learning. These systems became reliable enough to work well, even in potentially noisy home environments.
That's great AI making tech more inclusive. Okay, what about the really cutting-edge stuff, like self-driving cars?
Yeah, autonomous vehicles or robotaxis were definitely picking up steam. Baidu's Apollo program was already running pilot services in cities like Changsha, Guangzhou, and Beijing.
Pilot services open to the public.
Yep. You could book a ride through the Baidu Maps app. By 2020, they'd apparently clocked over 210,000 rides. And Baidu was talking about expanding testing to 30 cities within 3 years, aiming for actual commercial operation.
So, moving beyond just tests on closed tracks.
Definitely edging closer to real-world deployment. And Baidu wasn't alone. Their progress spurred competitors like WeRide, Didi Chuxing, and AutoNavi, the mapping company, to start their own autonomous driving trials.
Competition heating up.
For sure. And the source specifically flags AutoX's testing in Shenzhen as being particularly noteworthy
Why was that special?
because they were running fully driverless robotaxis, no safety driver behind the wheel.
Wow, completely empty car.
Apparently so, in the designated test zones. This leap was reportedly enabled by the development and use of specialized deep learning chips that significantly boosted the AI's driving accuracy.
That's a major milestone, taking the human backup out. Okay, one last example the source mentioned was AI-powered virtual staff. That sounds very sci-fi.
It does, doesn't it? But again, it was happening in China. And it's different from, say, virtual YouTubers, which are usually just avatars controlled by real people.
Right, VTubers have a person behind them, so these were purely AI.
Some of them, yes. The source gives the example of Xin Jiawei, an AI news anchor developed by Segu and the Xinhua News Agency.
An AI news anchor.
Yeah, a 3D avatar that uses synthesized speech to read news scripts. And apparently, it can even adjust its facial expressions based on the context of the news.
That's more sophisticated than just text-to-speech.
Definitely. Yeah. Another example was Xiao Pu, an AI bank teller from Baidu and SPD Bank.
An AI teller, like at the bank branch?
Sort of. Displayed on a screen, this digital character could hold surprisingly lifelike conversations. So much so that some people apparently suspected there was a human secretly operating it.
Huh. The Turing test in action at the bank?
Kind of. Though its main job wasn't deep philosophical discussion, but more bank reception duties, answering questions about documents needed for procedures, explaining processes.
So handling common queries.
Exactly. And the source predicted we'd see more of these AI receptionists appearing in various industries, especially with the push for contactless services during the pandemic. It suggests that AI for these kinds of basic conversational tasks had really hit mass production viability.
Okay, so looking at all these examples, vaccines, health codes, robotaxis, virtual staff, it really feels like China was deploying AI very broadly by 2020. What's the bigger picture takeaway from this rapid, wide-scale adoption?
I think the crucial point the source emphasizes is the advantage you get from adopting AI early and at scale,
Hmm.
especially with deep learning and reinforcement learning.
How so? What's the advantage?
These technologies fundamentally improve with more usage and more data. The more they run, the more data they process, the better they get. It creates this powerful positive feedback loop.
Ah, so it's like building momentum. The early adopters pull further and further ahead because their systems just keep learning and improving faster.
Exactly. It's not just about having the smartest scientists making breakthroughs, although that's important. For practical implementation, it's also about accumulating this operational experience, this know-how, and crucially, the refined data that comes from large-scale deployment.
So waiting on the sidelines wasn't really an option.
The source argues strongly against that. It suggests delaying AI adoption is a losing strategy. The challenge becomes finding cost-effective ways to get through that initial phase where the AI might not be perfect, where results might be lower, and just starting to build that experience and data advantage.
And the assessment was that Chinese tech companies were already pushing past that initial phase by 2020.
Yeah, they were seen as moving into a more mature stage of implementation, benefiting from that early large-scale investment and deployment.
Okay, so let's wrap this up. Our deep dive into China's AI landscape around 2020 shows a nation really firing on all cylinders,
Yet, they had made significant progress on the key ingredients: nurturing AI talent, building this incredible infrastructure for handling massive data,
including the AI trainers.
including the trainers, yeah, and backed by serious investment from both tech giants and the state that's supportive to yeah.
And this wasn't just theoretical. This foundation was already translating into a really diverse range of real-world AI applications.
Absolutely. From helping design vaccines to managing a pandemic to making smartphones easier for the elderly, running robotaxis, even creating virtual news anchors.
So the big takeaway is that, at least in China by 2020, AI wasn't some far-off future technology. It was very much a present-day reality, already having a tangible impact.
Precisely. It had moved beyond the lab and into practical, widespread use in many areas.
Which brings us to a final thought, something for you, our listener, to mull over. Considering China's approach, this combination of top-down strategic focus,
Mhm.
massive data mobilization, often involving significant human labor, and rapid deployment by major tech companies, what do you think the broader implications are?
Yeah, what might this mean for the societal and economic future of countries that are maybe slower on the uptake, slower to invest and integrate AI so deeply?
Or maybe think about how that specific emphasis on large-scale data annotation, the AI trainer model, could reshape the future of work, not just in China, but potentially globally.
It definitely gives you a lot to think about regarding the different paths AI development can take and the strategic choices nations are making.